Solution lesson, ideal and non-ideal solution. What are ideal solution? What are non-ideal solution? Differences between ideal and non-ideal solutions. Liquid solution can be classified into ideal and non-ideal solution on the basis of Rowlett's law. What are ideal solutions? The solution which obey Rowlett's law over the entire range of concentration known as ideal solution. The ideal solution possesses two important properties that are the enthalpy of mixing, the enthalpy change mixing the two component is equal to 0, and also the volume change during the mixing of the two components of the solution is also 0, called ideal solution. And what are non-ideal solution? In the case of non-ideal solution, what a non-ideal solution is, the non-ideal solution does not obey Rowlett's law over the entire range of concentration. Then it is called a non-ideal solution. The vapor pressure of such a solution is either higher or lower than the predicted by Rowlett's law. If it is higher, the solution exhibits positive deviation. If it is lower, it exhibits negative deviation. So now we are going to see the comparison in the properties of ideal and non-ideal solution. Ideal solution obey Rowlett's law at all temperature and concentration. Non-ideal solution do not obey Rowlett's law at all temperature and concentration. According to ideal solution, in the case of ideal solution, the vapor pressure is equal to, the vapor pressure of the solution is equal to vapor pressure, mole fraction of the solute and the mole from the vapor pressure of the pure component present in it. In the case of non-ideal solution, the vapor pressure of the solution is not equal to the mole fraction and the vapor pressure of the pure component present in the solution. Here the enthalpy of mixing of the two components in the case of ideal solution is equal to 0, and the volume change during the mixing of the two components is equal to 0. In the case of non-ideal solution, the enthalpy of mixing is not equal to 0, and the volume change for mixing two components is also not equal to 0. So ideal solution, delta H is equal to 0 and volume change also equal to 0. In the case of non-ideal solution, the enthalpy change and volume mixing is not equal to 0. Now consider the two components AA and BB. The molecules in the interatomic force between AA and BB is equal after mixing in solution. The AB interaction is equal to the interaction between AA and BB. That is equal. The equal interatomic forces are present in the molecule or the component in the case of ideal solution. But in the case of non-ideal solution, the interatomic interaction between AB is not equal to the individual component formed from it, the AA and BB. It is not equal in the case of non-ideal, it is equal in the case of ideal solution. In the case of ideal solution, it do not form azeotropes, that is constant boiling mixture, example ethanol and water mixture. Non-ideal solution form maximum boiling azeotrope, nitric acid and water. And in the case of non-ideal solution, mixture vapors will also have the same composition as the liquid. Example of ideal solution, ethanol acetone, methanol water. Example of non-ideal solution, phenol and aniline and chloroform benzene. So these are all the differences between ideal and non-ideal solution. Subscribe for more videos. Thanks for watching.